So looking on page 51 of your Springboard textbook, there are 3 paragraphs up top. I want someone to read that aloud after I read the learning targets. So up at the top, this is what we need to be able to do by the end of today. We need to be able to derive the distance formula. The distance formula hasn't been around forever. There was a point where it didn't exist, and so someone had to come up with this distance formula and figure out and give us this equation that would give us a distance between 2 points, no matter what those coordinates were. So we're going to put ourselves back in those mathematicians' shoes and figure this formula out for ourselves and make some sense of it. And then also we need to just apply it. We need to use that distance formula to find the distance between 2 points on a coordinate plane. Will someone read these 3 paragraphs for us aloud? Yes, ma'am?
In the previous activity, you use number lines to determine distance and to locate the midpoint of a segment. A number line is a one-dimensional coordinate system. In this activity, you will explore the concept of distance and midpoint on a 2-dimensional coordinate system or a coordinate plane. Use the coordinate plane and follow the steps below to determine the distance between points. Point 14 and P14 and Q139.
Thank you very much. So just to recap, because after you read a couple of paragraphs in the textbook, it's a good idea to just kind of pump the brakes and make sure you understand what it just said. Right here, we have already found lengths of segments, but they were only one-dimensional. It was the only coordinate that was changing was x. There wasn't any y. There wasn't a second dimension. And so when we found those lengths of segments that are in one dimension, how did we find that distance? Yes, ma'am?
We used absolute value.
Absolute value of what?
The difference.
Right, so we took those 2 coordinates, and we took their difference, and then the absolute value of the difference. Awesome. So now we're going to look at it in 2 dimensions. We also found the midpoint of 1 dimension. When we hear the word midpoint, what do we need to think of? Middle, okay. How did we find the coordinates of the midpoint in that previous activity? Grace is the only one that remembers. What's up?
Oh, okay. Do what you did to find the distance and then divide it by 2.
So you find their difference and then divide their difference by 2? I disagree with that. Let's look at page 42 in your Springboard textbook. Page 42. At the top of page 42, it reads, the midpoint of a segment is halfway between its endpoints. So if you know the coordinates of the endpoints, you can average them to find the coordinate of the midpoint. When you hear midpoint in this class, you're trying to find the midpoint, whether it's 1-dimensional or 2-dimensional, you need to think about average. You're taking the average of those 2 endpoints. And so how you find the average of a set of numbers is you add them up and divide by however many there are. So since every single segment has 2 endpoints, there's always going to be 2 values. We add those 2 values up and divide by 2. So what we've done thus far was distance. We took the absolute value of the difference of the coordinates, and then midpoint, we just found the average of those coordinates, or what was right in the middle. Just take the average of it. But now we need to do it in a 2-dimensional coordinate system, or you can also call it a coordinate plane, because a plane has 2 dimensions. The geometric object plane has 2 dimensions. This 2-dimensional coordinate system, it is also called the Cartesian coordinate system, because it was invented by this brilliant man over here on the right in this section of my notes. The Cartesian coordinate system, or this 2-dimensional coordinate system, was developed by the French philosopher and mathematician René Descartes in 1637 as a way to specify the position of a point or object on a plane. So we're gonna go ahead and answer items 1 through 3 on this page. And the first one says, plot points P and Q on the coordinate plane, then draw segment PQ. So I want you to do that on your own piece of paper as quickly as possible. The line doesn't have to be perfect. Whenever you plot points, you not only have to put the capital letter that's representing that or naming that point, but you also need to put its coordinates. You need coordinates, which are the numbers, the x and y values, and you also need the capital letter that is that point's name. So please appropriately plot those points. So our end goal is to find the length of this segment. Find the length of segment PQ. And the notation that we've used for that, and a lot of us really need to finally figure out the difference between talking about the object segment PQ and its notation versus talking about its length. So our end goal is to find the length of segment PQ. This means object segment PQ, and this is our end goal, is to find the length of segment PQ. That's our end goal. So we're because it is not perfectly horizontal like a number line or perfectly vertical, we can't just count. You can't just say 1, 2, 3, 4, 5, 6. And then it's 6 units long. Like, what is each jump? Like, you're just making up units. So we have to come up with a systematic way that we can apply every single time we need to find the distance between any 2 points. So item 2 here, this is critical thinking. Draw a horizontal segment, horizontal, like the horizon, you look out into the horizon. Draw a horizontal segment PR. I would have preferred if they used the notation, so scratch this out and this. So draw horizontal segment PR. And vertical segment QR. Now both of those segments have endpoint R. Is R on our diagram yet? No. So we need to find the location of R that satisfies this criteria. So we're going to have a horizontal segment PR, we're going to have a vertical segment QR to create right triangle with vertices PQR. So we're going to create a right triangle here. But the right angle, its vertex must be point R. So you need to figure out where you're going to place point R so that it satisfies this statement, this sentence. So please find the location of point R. And then item 3 says, what are the coordinates of that point R? Just follow the instructions. Alright, so I have some horizontal segment whose one of its endpoints is P, and the other endpoint is R somewhere. So if it contains point P and it has to be horizontal, then it's going to be something like this. That's a horizontal segment that contains point B. I don't know if point R is going to be over here or if point R is going to be over here. I don't know that yet. But I know that this horizontal segment has got to go through P. I also know that this that there's vertical segment goes through Q. So this vertical segment goes through Q. So this is a vertical segment that contains Q. And then now I can see, okay, these 2 segments intersect there. And so because both of these segments, horizontal and vertical, contain the same endpoint, point R, that means it has to be here. And so what are the coordinates for this point are?
13, 4.
What do you notice about the coordinates of this point R and the two original points? What are the similarities? I saw a bunch of people raise their hand. You guys, Keaton, go ahead, bro.
R has the x value of Q and the y value of P.
Very good, okay? And so where this is going to come into play later, where every single coordinate point has an x and a y value. So we have an x and a y value here, we have an x and a y value here, and we have an x and a y value here. But we need to somehow be able to distinguish between which x value we're talking about. So if these are the 2 points that we're trying to find the distance between, how long is that segment? Well, then I say that this is my first point. And so I'm going to call this x1 and y1. I'm putting little subscripts, is what they're called, next to those coordinates x and y. Like a submarine goes underneath water, so do subscripts. They go underneath. You also have superscripts. Those go above the letters, it's like exclamants. So this is my first point. This is my second point. So I can call this x2 and y2. And so the similarities is exactly what Keegan said, is that point R shares the same x value, that x2, but it shares the y value of point P, which is y1. Very good. So we got those coordinates, and that's wonderful. Now, what's going to happen next is I can't flip pages back and forth and this writing follow it. So you all are going to turn to the next page. However, this is going to continue to stay projected on the board. So it's going to be difficult to stay on the same page today. Buzzy nailed it. So we are on page 52 right now. I know that's not what's being projected, but you should be reading page 52. Item 4A, what is how you read the capital P and the capital R right next to each other? What is the length of segment PR? That is how we need to read it, that's how we need to interpret it, that's how we need to say it to one another. What is the length of segment PR? The length of the horizontal leg of that right triangle. So y'all are going to keep flipping back and forth, going back and forth, back and forth. I'm just going to stay chilly right here. Okay? Now, so we're trying to figure out what the length of this red segment is. Now, this red segment, it's colored mine, how many dimensions is that right now? Just one, right? Because I understand that these points both have an x and a y coordinate, but only one of the coordinates values are changing. And which coordinate is that? Are the x changing or the y changing? The x values are changing, right? I'm starting here at 1, where x is equal to 1, and then I'm moving over to x is equal to 13. So if I need to find the length of a horizontal segment, one-dimensional segment, what did we say? So I'm going to take the absolute value of their difference. And so please make sure that you're practicing, make sure that you're using the correct notation. The length of segment PR. I don't have a bar above it, because I'm not talking about the object, I'm talking about its length. So the length of segment PR is equal to, and then I have the bars for the absolute value. I'm going to take the difference of these two coordinates. And so I'm going to take the difference of x2 and x1. And so the length of segment PR is equal to what? Positive 12. Remember, distance and length is always positive. Distance and length is always positive.